All right, in these last two examples, we're going to look at finding a formula for a rational function given some information about the function, about its zeros and its vertical asymptotes or its horizontal asymptotes. And so we're going to try and write a formula. So let's take a look at this first one. We want to write a possible formula for a rational function that has the following properties. And we can check this using a graphing calculator or with something like Desmos. So, so let's take a look at first of all, we have, let's just write f of x is equal to something, and it's going to be a rational function, so it's going to have a numerator and the denominator. Now remember, the zeros occur whenever the numerator is 0. So if we have a 0 at -1, then we have to have a factor of x plus 1 in the numerator. Okay? Because then at -1, that factor would be 0. We also have a 0 at x equals 4, which means that the numerator also has to have a factor of x minus 4, because if we plug in 4 to that factor, we would get 0. All right. So, so if we're given the zeros, then we know the numerator would have to have those factors. Now, it also says we have a vertical asymptote at x equals -2. All right, now the vertical asymptotes occur when the denominator is 0. All right, so that means that the denominator has to have a factor of x plus 2, because when x is -2, that would be 0. And we also need to have a horizontal asymptote. Remember, horizontal asymptotes have to do with the long run behavior of the function. So we're looking at what happens as x goes to either plus or minus infinity. And remember that in order to look at the long run behavior of a rational function, we just look at the leading term of the numerator over the leading term of the denominator. So in the long run, as x goes to infinity, as we have it now, this looks like it's going to be x squared, right? The leading term, if I FOILed this out, would be x squared in the numerator and an x in the denominator. So as it is now, that would reduce down to x, and that is not going to go to -1. So we have to think about what does this the ratio of these leading terms have to look like in order to get it to go to a -1. Well, I have to have a squared here, right? And I'd have to have a -1 times this whole thing. And then that would go to -1. Oops. -1 equals -1, right? When I reduce it down. So I need another factor of x in the denominator. So I could just put in an x here, and then when I FOIL it out, I get the leading term of x squared. And really, I could put in any linear factor. I can put in any linear factor here for the instead of x. I just use x because it's nice and simple. But I could use any linear factor other than, right? Other than the factors that would cause a hole, because then I'm not going to get an asymptote, I'm going to get a hole at that point. So other than x plus 1 or x minus 4 will work. So as it says up in the problem statement, there's obviously more than one solution for this problem, or for this problem. But okay, let's not forget, I want this to be -1. So I need a factor of -1 up here. So -1 times this, or I could just say negative of all of that. So I have to have a factor of -1 as well. All right, so now you can check it. You can look at the leading term of the numerator would be a minus x squared, and the denominator would be x squared. And then when we look at the limit as x goes to infinity, it would go to -1. All right, so that takes care of everything. Now we just want to double check that with Desmos. All right, so I took my function and put it into Desmos, and here's what it shows me. So let's just verify. We have to have a 0 at -1 and at 4. And you can see that it crosses the x-axis here at -1 and at 4. So those are our zeros, right? 4, 0, and -1, 0. And we have to have a vertical asymptote at -2, which we do. It looks like the function doesn't cross that vertical asymptote. Now, because the other factor in the denominator was x, right? The denominator would also be 0 at 0. So we also have a vertical asymptote at x equals 0 as well. I didn't show it on there, but x equals 0 is the y-axis, so it would be a line right on top of the y-axis. And then we need a horizontal asymptote at -1, and you can see too that we have the horizontal asymptote at -1. All right, so I will that takes care of that example. I'll meet you for the last example.